universe is expanding at an accelerated rate. But what about the future? Do we know how our universe is going to end? We know about our universe's past. The Big Bang Theory predicts that all matter, time, and space began in an incredibly tiny, compact state about 14 billion years ago. And we know about the present. Scientists' observations of the movement of galaxies tell us that the universe is expanding at an accelerated rate. But what about the future? Do we know how our universe is going to end? Cosmologists have three possible answers for this question, called the Big Freeze, the Big Rip, and the Big Crunch. To understand these three scenarios, imagine two objects representing galaxies. A short, tight rubber band is holding them together. That's the attractive force of gravity. Meanwhile, two hooks are pulling them apart. That's the repulsive force expanding the universe. Copy the system over and over again, and you have something approximating the real universe. The outcome of the battle between these two opposing forces determines how the end of the universe will play out. The Big Freeze scenario is what happens if the force pulling the objects apart is just strong enough to stretch the rubber band until it loses its elasticity. The expansion wouldn't be able to accelerate anymore, but the universe would keep getting bigger. Clusters of galaxies would separate. The objects within the galaxies, suns, planets, and solar systems, would move away from each other until galaxies dissolved into lonely objects floating separately in the vast space. The light they emit would be redshifted to long wavelengths with very low, faint energies, and the gas emanating from them would be too thin to create new stars. The universe would become darker and colder, approaching a frozen state also known as the Big Chill, or the heat death of the universe. But what if the repulsive force is so strong that it stretches the rubber band past its elastic limit and actually tears it? If the expansion of the universe continues to accelerate, it will eventually overcome not only the gravitational force, tearing apart galaxies and solar systems, but also the electromagnetic, weak and strong nuclear forces, which hold atoms and nuclei together. As a result, the matter that makes up stars breaks into tiny pieces. Even atoms and subatomic particles will be destroyed. That's the Big Rip. What about the third scenario, where the rubber band wins out? That corresponds to a possible future in which the force of gravity brings the universe's expansion to a halt and then reverses it. Galaxies would start rushing towards each other, and as they clumped together, their gravitational pull would get even stronger. Stars, too, would hurtle together and collide. Temperatures would rise as space would get tighter and tighter. The size of the universe would plummet until everything compressed into such a small space that even atoms and subatomic particles would have to crunch together. The result would be an incredibly dense, hot, compact universe. A lot like the state that preceded the Big Bang. This is the Big Crunch. Could this tiny point of matter explode in another Big Bang? Could the universe expand and contract over and over again, repeating its entire history? The theory describing such a universe is known as the Big Bounce. In fact, there's no way to tell how many bounces could have already happened, or how many might happen in the future. Each bounce would wipe away any record of the universe's previous history. Which one of these scenarios will be the real one? The answer depends on the exact shape of the universe, the amount of dark energy it holds, and changes in its expansion rate. As of now, our observations suggest that we're headed for a big freeze. But the good news is that we've probably got about 10 to the 100th power years before the chill sets in. So don't start stocking up on mittens just yet.